How we are going to define g naught f here? G naught f can be written as g of f of x. So first we will define the functional value of f, then we will define the functional value of g. We will write cos x square. Instead of writing after x, write here cos square x, because cos x square is completely different from cos square x. Now what is g naught f? G naught f is a function from x to x. It is an identity function on x. Thus we can define g naught f as identity function under x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So in this session, we are going to study about the composition of function as well as invertible function. We have learnt about the one-one function, onto functions and bijective function. Let's see here the composition of function, which is a function of a function. So what do you mean by a composition of a function? So let's see that. Now let us consider a function f from a to b and a function g from b to c. So let these relations, that is f from a to b and g from b to c, be two functions. Then g naught f, so it's a function from set a to set c. This is a function from set a to set c that is said to be the composition of a function. So here we can also define f naught g also. So how we are going to define g naught f here? G naught f can be written as g of f of x. So first we will define the functional value of f, then we will define the functional value of g. Similarly, we can also define f naught g of x, which can be considered as f of g of x. So here g function is derived first and later we will take the value of the function f. So these two functions, that is g naught f and f naught g, are called as composition of a function or function of a function. Let us take an example here. I have taken f of x is equal to x square and g of x is equal to log x. So let us find what is g naught f of x and f of g of x. So g naught f of x can be written as g of f of x. So f of x is nothing but x square. So we can write x square here. Now suppose if we have g of x, we will write it in the form of log x. Here we have x square. So therefore this can be written as log x square. Also we can write this as 2 log x. See, this is what the composition of g naught f. Let us consider f naught g. F naught g of x. So which is nothing but f of g of x. So what is g of x? G of x is nothing but log x. So we'll write here log x. Now suppose if we have f of x, we write it as x square. So that is in the place of x, here we have log x. So this becomes log x whole square. So this is completely different from your 2 log x. So this is log of x square and this is log x whole square. So clearly we can define both the function, that is g naught f of x as well as f naught g of x. Also we can see here the value of the two functions are different. We can conclude that g naught f is not equal to f naught g. That is, it is not commutative. Let us take one more example. We are taking f of x is equal to cos x, g of x is equal to e power x here. So now f of g of x, that is f naught g of x we are taking. So what happens now? G of x means e power x. So if you have x, it has to be written in the form of cos x for a function f. So therefore this becomes cos e to the power x. So similarly, let us consider g naught f of x. So g, what is f of x here? F of x is here cos x. So we'll write this as cos x. Now suppose we have g of x, we have to write it in the form of e power x. So this can be written as e to the power cos x. So the value of f naught g is cos e power x and g of f is e to the power cos x. So here also we can see f naught g is not equal to g naught f, but both the functions are defined, it has some value, but they are not commutative. Now let's find the composition of f naught g and g naught f for the given function. Here f of x is equal to 8x cube and g of x is equal to x to the power 1 by 3. We are supposed to find out g naught f and f naught g. So here g naught f of x is g of f of x. So that is equal to g of, what is f of x? We have 8x cube. G of x means it has to be written in the form of x to the power 1 by 3. So this can be written as 8x cube to the power 1 by 3. We can write 8 as 2 cube. So therefore 2 cube x cube to the 1 by 3 here, or we can take cube root of 8, which is nothing but 2. X cube and 1 by 3, 3 get cancels. So the value is equal to 2x here. Let's check for f naught g of x, that is f of g of x. Now g of x means x to the power 1 by 3. So outside we have f. F of x has to be written in the form of 8 times x cube. So what is there here? In the place of x we have x to the power 1 by 3 whole cube. So here 3 get cancelled, so we have 8x. So this is our f naught g. Next one, find g naught f and f naught g. If f is a function from real number to real number and g is a function from real numbers to real numbers, are given by f of x is equal to cos x and g of x is equal to 3x square. Show that g naught f is not equal to f naught g. So here, let us find out the first one, that is g naught f. So g naught f of x can be written as g of f of x. So what is f of x? F of x is cos x. So in the place of f of x, just write down cos x. Now g of x has to be written in the form of 3x square. But in the place of x here, we have cos x. So we will write cos x square. Instead of writing after x, write here cos square x, because cos x square is completely different from cos square x. Okay, so here cos is repeating 2 times, so therefore we need to write it in the form of cos square x, not cos x square. So now g naught f of x is what? We got 3 cos square x. Now let's see f naught g of x. Now f naught g of x is f of g of x. Now what is g of x? They have given 3x square. So we have to write here 3x square. Now suppose here f of x, we have to write it in the form of cos x. So here this can be written as cos. In the place of x, we will write 3x square. So this is the value. So clearly we can observe here, this is 3 cos square x and this is cos 3x square. So therefore clearly g naught f is not equal to f naught g. Next question, we are supposed to find out f naught g to the minus half and g naught f to minus half, where f and g are functions from real numbers to real number. F of x is modulus x and g of x is the greatest integer function. So here we also need to show that g naught f is not equal to f naught g. So let us take f naught g of x. So f naught g of x means f of g of x. So what is g of x? G of x is a greatest integer function. So f is greatest integer function we need to take here. So f, so what is the value we need to take? It is minus half. So minus half means it is 0, minus 1, minus 2 and here it is 1. So minus half means minus 0.5. So what is the greatest integer which is less than or equal to this number? That is equal to -1. So clearly here we can write this as value as -1 because -1 is the integer which is less than or equal to the 0.5, -0.5. Now f of -1, the function f is what? The modulus function. So here -1 has to be taken under the modulus. So the value you will get is 1. Next, let us take g0 f of x. So g0 f of x is nothing but g of f of x. So g of modulus x we need to take. So g of, so modulus of -12, it is, so which is equal to half. So how the function g is defined? G is the greatest integer function, that is 1/2. So 1/2 is again a 0.5. Here you have -1, 0, +1 on the number line. So 1/2 is the value between 0 and 1. So the greatest integer which is less than this number, clearly it is 0. So therefore the value of this is 0. Now you can see here the value is 1. Here the value is 0. Clearly we can write g0 f is not equal to f0 g. Next one, find g0 f and f0 g if f and g are the function from set of real numbers to real number, f of x is sin x and g of x is x cube. Show that g0 f is not equal to f0 g. Let us consider g0 f of x, which is g of f of x. What is f of x? F of x is sin x. So here it becomes g of sin x. Now if we have x, it has to be written as x cube. Now since we have sin x here, it is sin cube x, or you can write it as sin x whole cube. Now next we will take f0 g of x. So which becomes f of g of x. Clearly this is f of g of x is x cube. So let's write it as x cube. If we have x, it has to be written in the form of sin x for f. So therefore this becomes sin x cube. So clearly sin cube x is completely different from sin x cube. So we can show that g0 f is not equal to f0 g. Hence proved. Next question. Let f be a function from the domain 2, 3, 4, 5 to codomain 3, 4, 5, 9 and g is a function from 3, 4, 5, 9 to 7, 11, 15. Be function defined as f of 2 is equal to 3, f of 3 is equal to 4, f of 4 is equal to 5, f of 5 is equal to 5. And g of 3, g of 4 is 7 and g of 5, g of 9 is 11. Find g0 f. So g0 f is a function from A to C. So that is g0 f is a function from 2, 3, 4, 5 to 7, 11, 15. Now we know to suppose g0 f of 2, g0 f of 3, g0 f of 4 and g0 f of 5. So these are the values we need to find. Now this can be written as g of f of 2. What is f of 2? F of 2 is 3. So here we can write in the place of f of 2, 3. Now we got g of 3. What is g of 3? That is equal to 7. Next we have g of f of 3. What is f of 3 we have? It is 4. So we get g of 4. What is g of 4? Again it is 7. Next it is g of f of 4. What is f of 4 we have? F of 4 is 5. So it is g of 5 we get. G of 5 is 11. Next we have g of f of 5. What is f of phi we have? F of phi is 5. So it is g of phi again. So g of phi is 11. Thus we have defined g naught f for every value in the domain. So this is all about the composition of function. Next, let us study about the invertible function. Now before that, invertible function, let us see what is identity function. We know that identity function is a function from the set of real numbers to real number where f of x is equal to x only. That is, whatever the value you input, the same output you will get. Thus, we can say a function which gives the same value as inputted, that is f of x is equal to x, where x belongs to the set of real numbers, is nothing but identity function. Now since we have learned the composition of function, let us see what is identity function under the composition of function. Now we have learned g naught f and f naught g. So let us consider f from function a to b, g is a function from b to a. So clearly you can see it is a function from a to b and g is a function from b to a. Now what is g naught f? G naught f is a function from x to x. It is an identity function on x. Thus, we can define g naught f as identity function under x. Now, f naught g is a function from y to y, which is an identity function of y, where f naught g can be written as an identity function under y. So, the composition of a function becomes an identity function only when f is a function from a to b and g is a function from b to a. So, domain to codomain is reverse, that is codomain to domain in the set of g as a function. So, thus, inverse of a function is nothing but a function f from a to b is said to be invertible if there exists a function g from b to a such that the composition of two functions are identity functions. So, you know that identity function. So, if you input the value x, you should get x. If you input the value y, you should get y. Thus, for a function f from a to b, if there exists a function b to a, then the composition of f naught g and g naught f for identity function, then we say that it is invertible function. The function g is called the inverse of f. We call g as inverse of f and we write it as f inverse. So, instead of g, we can also write it in the form of f to the power minus 1, that is f inverse. So, note that if f is an invertible function, that means if f is a function from a to b, there exists a function g from b to a so that the composition g naught f and f naught g are identity function. If suppose they are identity function, then it has to be a 1-1 function and onto function. That is, both g naught f and f naught g must be a bijective function. Therefore, we can also define the invertible function, one more definition, that if f is invertible, then f must be 1-1 and onto. That is, if f is bijective, then f is invertible. So, we can define two definitions for a invertible function. One is, if f is invertible, then f has to be bijective. The other one is, if f is said to be invertible, then there should exist a function g from b to a such that g naught f and f naught g are identity function. So, we can also find whether the given function is invertible or not from the composition of function or by proving that the given function is bijective. Now, here is an example. State with reason whether the following functions have inverse. So, we can clearly see the domain and codomain of the given function here. So, the ordered pairs are given here. So, we can clearly see that 1, 2, 3, 4 have unique image and every element in the domain is having an image in the codomain. So, clearly we can say this is 1-1 and onto. So, therefore, the given function have inverse. Next, g is a function from 5, 6, 7, 8 to 1, 2, 3, 4, 5, 4, 6, 3, 7, 4, 8, 2 is the given ordered pairs. So we can see here we have 5, 6, 7, 8 and we have here 1, 2, 3, 4. So we have 5 to 4, 6 to 3, 7 to 4, 8 to 2. So clearly the given function is a function but it is not onto, since for 1 we do not have any pre-image in the domain. So that is, for y belongs to y, we doesn't have x belongs to x in the domain. So clearly this is not onto function. So if it is not onto, then f is not bijective, therefore f does not have inverse. Next we have, consider f function from set of real number to real number given by f of x is equal to 4x plus 3. Show that f is invertible. Find the inverse of x. So we have two methods of finding f. First is we can show g naught f and f naught g or identity function. If they are identity function, then f inverse exists. We can write f inverse. The other way is that we can show f is 1, 1, f is onto, therefore f is bijective, f inverse exists such that we can write f inverse. Now first let us prove this theorem under the composition of g naught f and f naught g. Now if f of x is equal to 4x plus 3, here we have f is a function from R to R, then there should exist g, a function from R to R, which is defined by g of y. So if I take this y in the form of 4x plus 3, then x can be written as y minus 3 by 4. So therefore here g of y can be written as y minus 3 by 4. Now let us consider g naught f of x, which is g of f of x. Now since my domain value is x, I should get the result x only to show that g naught f is identity. So therefore, what is f of x we have? F of x is 4x plus 3. Now we have y, it has to be written in the form of y minus 3 by 4. So therefore in the place of y we have 4x plus 3. So we have 4x plus 3 minus 3 by 4. 3 get cancels. We have 4x by 4. 4 get cancels. We got x. So clearly we have g naught f of x is equal to x, which is an identity function under x. Now let us consider f naught g of y. So this can be written as f of g of y. So what is g of y here? G of y is y minus 3 by 4. So we have here y minus 3 by 4. So if we have f of x, then it has written in the form of 4x plus 3. We have 4 y minus 3 by 4 plus 3. 4 get cancels. We have y minus 3 plus 3. Minus 3 plus 3 cancels. We got y. So this implies f naught g of y is equal to y, which is an identity function under y. So clearly we got g naught f of x as our identity function in x and f naught g of y as an identity function in y. So therefore g of y, which can also be written in the form of f inverse of x, which is equal to, instead of y minus 3 by 4, we can write x minus 3 by 4 is the inverse of f. The other way is to show that we can show f is 1 function, f is onto function, then we can show it is a bijective function, and then again we can write f inverse of x is equal to x minus 3 by 4. So thus this is the method to prove the given function is a 1 onto bijective and thus f inverse exists, or to show that the given function is invertible. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.